close your eyes. Take a slow, deep breath. Imagine a vast, powerful thunderstorm churning miles below you. You can almost hear the distant rumble of thunder, feel the electric energy in the air. We are taught to look down for lightning, for the brilliant flashes that connect the clouds to the earth. But what if the real magic, the true secret, happens not below, but above the storm? What if, in the silent, near vacuum of the upper atmosphere, colossal, silent fireworks bloom into existence for just the blink of an eye? Tonight, we journey into that secret world. We will explore the mystery of red sprites, ethereal signals from the edge of space, and uncover a beautiful phenomenon that was hidden from us for centuries. Prepare to drift away on a story of light, power, and the quiet wonders of our own planet. For as long as humanity has watched the skies, we have been in awe of thunderstorms. We understood the bright, jagged lines of lightning that struck downwards. It was a familiar, earthly power. But for decades, pilots flying high above the clouds would report something strange. They spoke of fleeting, red flashes high above the storm tops, massive structures of light that appeared and vanished in an instant. These reports were often dismissed. They were attributed to reflections, tired eyes, or tricks of the light. The scientific community had no framework for lightning that went up towards space instead of down towards the ground. So the stories remained just that, stories. Whispers of atmospheric ghosts seen only by a select few with no proof to bring back home. This was a mystery hiding in plain sight, waiting for the right moment and the right technology to be revealed to the world. Our story of discovery begins in the year 1989. Scientists from the University of Minnesota were testing a new low-light television camera. By sheer chance, on the night of July the 6th, they aimed their equipment at a distant thunderstorm. As they watched the familiar flashes below, their screen captured something unbelievable. For just 2 frames of the video, a pair of giant twin pillars of reddish light appeared high above the clouds, reaching dozens of miles into the sky. It was the first time this phenomenon had ever been captured on camera. The pilot's stories were not hallucinations. The atmospheric ghosts were real. This single, accidental recording opened a brand new field of atmospheric physics, proving that the sky above a storm is just as active and far more mysterious than the storm below. So, what is a red sprite? Imagine a cosmic jellyfish or the branching roots of a celestial tree painted in a soft, crimson light. They are not like traditional lightning. They are not hot, searing channels of plasma. Instead, they are a form of cold plasma, more akin to the gentle glow inside a fluorescent light tube. They erupt from the tops of thunderclouds, shooting upwards towards the ionosphere, the electrically charged layer of our atmosphere that borders space. Their shapes are ethereal and varied. Sometimes they are vast, circular splashes of light called sprites' halos. Other times they form intricate, descending tendrils of red and blue light, a structure so delicate and complex it seems more like a work of art than a natural phenomenon. They are silent, beautiful, and utterly massive. The distinct, beautiful red color of a sprite is not random. It is a direct message from the air itself. Sprites occur at very high altitudes, between 30 and 55 miles up, in a layer of the atmosphere called the mesosphere. Here the air is incredibly thin, almost a vacuum. When a powerful electrical discharge occurs, the energy primarily excites the most abundant molecules present. Nitrogen. Just like the gas in a neon sign glows when electricity passes through it, the nitrogen molecules in the thin upper atmosphere are energized and release that energy as light. And the specific color they emit at these low pressures is a soft, ethereal red. The faint blue whispers of light, sometimes seen in their lower tendrils, are where the atmosphere becomes slightly denser, causing nitrogen to glow in a different hue. The color itself tells a story of altitude and pressure. Let us look closer at the anatomy of a sprite, this beautiful atmospheric creature. The most common form is often called a jellyfish sprite, and the name is wonderfully accurate. It begins with a bright, compact head, a burst of light that can be several miles wide. Below this, a cascade of wispy, branching tendrils unfurls, stretching downwards for 20 or even 30 miles. These tendrils are the most intricate part, glowing in hues of red, violet, and blue as they reach down into denser air. Above the main body, a faint, expansive red glow. The sprite halo often precedes the main event, like a gentle announcement of the spectacle to come. This entire structure, born and extinguished in less than 1/10 of a second, is a perfectly organized, colossal discharge of electricity, with a form as delicate as it is powerful. To truly appreciate a red sprite, we must understand its immense scale. When we see a flash of lightning from our window, it might seem large, perhaps a mile or two long. Now imagine a single red sprite. The top of the sprite can reach altitudes of nearly 60 miles, brushing the very edge of space. The entire structure, from the top of the halo to the bottom of the lowest tendril, can be 30 miles tall. That is taller than Mount Everest, stacked on top of itself more than 5 times. In width, a large sprite event can cover an area of hundreds of square miles. It is a silent, fleeting light show on a truly planetary scale, a single flash that could cover an entire city. Yet it is so faint and so fast that it remains invisible to most of us on the ground below. The realm where sprites are born, the mesosphere, is a mysterious place. It is a silent, transitional zone, too high for weather balloons and airplanes, yet too low for satellites to orbit. It is a world of noctilucent clouds made of ice crystals, and where meteors burn up as shooting stars. The air here is thousands of times thinner than at sea level. It is into this cold, quiet, and nearly empty space that sprites erupt. They are a bridge, a momentary electrical connection between the powerful, weather-filled world of the troposphere below and the electrically charged, space-like world of the ionosphere above. They exist on the shoreline of space, a luminous expression of Earth's own electrical energy reaching out into the cosmos. One of the most defining characteristics of a sprite is its fleeting nature. To our eyes, a camera flash seems instantaneous. A red sprite is even faster. The entire event, from the initial halo to the fading of the last tendril, typically lasts for only a few hundredths of a second. Some elements exist for only a few milliseconds. This is why they were a mystery for so long. Without high-speed cameras, a sprite is just a perception of a faint, reddish blur on the horizon, something you can never be sure you actually saw. It is a perfect example of a phenomenon that exists just beyond the threshold of normal human perception, a secret the sky kept simply by being too quick for our eyes to follow. What kind of earthly power could create such a celestial spectacle? The answer lies in a very specific and very powerful type of lightning. Most lightning we see is negative lightning, carrying a negative charge to the ground. But a small percentage of lightning strikes are immensely more powerful and carry a positive charge. These are called positive cloud to ground or positive CG strikes. A single positive CG can be 10 times more powerful than a typical lightning bolt. When one of these monster bolts strikes the ground, it suddenly removes a huge amount of positive charge from the top of the thundercloud, leaving behind an intensely powerful imbalance. It is this sudden, massive electrical shift that sets the stage for the sprite to be born high above. Imagine the top of a thundercloud as the positive terminal of a giant battery, and the ionosphere high above as the negative terminal. When a massive positive lightning strike hits the ground, it is like a huge amount of that positive charge is suddenly drained away. This creates a powerful, momentary electric field, a quasi-electrostatic field, between the top of the cloud and the ionosphere. For a fraction of a second, the electrical potential is immense. The air in the mesosphere, thin as it is, cannot withstand this force. It breaks down. Electrons are stripped from their atoms, and they cascade downwards, creating the glow we see as a sprite. It is not lightning in the traditional sense, but the atmosphere itself, glowing in response to an immense, invisible field of force. Red sprites are not the only phantoms dancing above the clouds. They are part of a larger, more diverse family of phenomena, collectively known as transient luminous events, or TALCEs. If sprites are the intricate jellyfish, then their cousins, the elves, are something else entirely. Elves are even more difficult to see, and even larger in scale. They are not structured pillars of light, but something far grander and more ethereal. They are a different kind of atmospheric response to the power of the storm below, a testament to the complex and varied ways our planet's energy is expressed in the upper atmosphere. Each TLE has its own personality, its own cause, and its own unique and fleeting beauty. Let us picture an elf. The name is actually an acronym, emissions of light and very low frequency perturbations due to electromagnetic pulse sources. But the image it creates is fitting. Imagine dropping a stone into a perfectly still, dark pond. A ripple expands outwards in a perfect circle. An elf is like that, but in the sky. It is a vast, donut-shaped ring of reddish light that rapidly expands outwards, sometimes reaching diameters of over 200 miles. It appears even higher than a sprite, at the very bottom of the ionosphere, and lasts for less than a single millisecond. It is a ripple of light in the fabric of the upper atmosphere, a fleeting blush on the cheek of the night sky. The cause of an elf is directly tied to the raw power of the lightning strike itself. A powerful lightning bolt acts like a colossal radio antenna, releasing an incredibly intense electromagnetic pulse, or EMP. This pulse travels outwards in all directions at the speed of light. When this powerful wave of energy reaches the ionosphere, it energizes the nitrogen molecules there, causing them to glow in that same signature reddish hue. Because the pulse expands in a sphere, the part that intersects with the flat layer of the ionosphere creates that perfectly expanding ring of light. An elf is the visible signature of the thunderclap's electromagnetic echo, heard not as sound, but seen as light at the edge of space. There is another member of this ghostly family, one with a very different character, the blue jet. While sprites and elves are diffuse, glowing phenomena high in the mesosphere and ionosphere, blue jets are more focused, more energetic, and occur much lower down. They are born directly from the electrically supercharged core of a thunderstorm. Unlike sprites, which are a secondary effect of a ground strike, blue jets are a direct electrical discharge, a form of lightning that has decided to travel up instead of down. They are brilliant, conical bursts of blue light that erupt from the cloud tops and shoot upwards at incredible speeds. Imagine watching a powerful thunderstorm from above. Suddenly, from the very top of the cloud, a brilliant cone of blue light erupts, rocketing upwards toward the stratosphere. This is a blue jet. They can reach altitudes of 25 to 30 miles, well into the ozone layer. They are much brighter than sprites, but are still incredibly rare and difficult to capture. Their vibrant blue color comes from the same source as the red of the sprites, excited nitrogen, but at the lower, denser altitudes where jets form, nitrogen glows with a blue and violet light. They are a powerful upward stroke of lightning, a direct electrical conversation between the heart of the storm and the upper atmosphere. Together, sprites, elves, and blue jets form the spectacular family of transient luminous events. Each is a different answer to the same question. What happens to the immense energy of a thunderstorm? Sprites are the gentle, delayed response to a powerful ground strike. Elves are the instantaneous, expanding echo of the electromagnetic pulse. And blue jets are the direct, forceful upward ejection of electrical charge. They are three different dialects in the language of atmospheric electricity. Studying them together helps us understand the complex, interconnected system that links our weather, our atmosphere, and the very edge of space, revealing a hidden layer of activity we never knew existed. These transient luminous events are not confined to one small part of the world. They are a truly global phenomenon. Wherever powerful thunderstorms form, sprites are possible. They have been observed over the Great Plains of North America, over the tropical storm systems of Africa and South America, and over the oceans of the world. The key ingredient is not geography, but meteorology. All that is needed is a sufficiently powerful thunderstorm, one that is capable of producing those immense, positive cloud-to-ground lightning strikes. This means that on any given night, somewhere on Earth, it is almost certain that these silent, beautiful light shows are taking place, a secret dance continuing, unseen, above the clouds. If they happen all over the world, why are they so incredibly difficult to see? There are several reasons. First, you need a clear line of sight to the sky above a distant thunderstorm, often one that is 100 to 200 miles away. This allows you to look over the top of the storm. Second, your viewing location must be incredibly dark, far away from the light pollution of cities. Any ambient light can easily wash out the faint glow of a sprite. And third, you have to be looking at the right place at the right time. The sprite itself lasts for a fraction of a second. Even under perfect conditions, you can stare at the sky for hours and see nothing. It takes patience, darkness, and a great deal of luck to witness one with the naked eye. The scientists and storm chasers who hunt for sprites are modern-day ghost hunters, but their tools are not paranormal detectors. They are instruments of precise science. Their primary tool is the high-sensitivity, high-speed camera. These cameras can capture thousands of frames per second and can see light levels far below what our own eyes can detect. They are often paired with very low-frequency radio receivers, which can detect the specific radio signature of a positive lightning strike that is likely to produce a sprite. By linking the radio detection to the camera, they can pinpoint the exact moment a sprite is born. It is a delicate and technical pursuit, a high-tech search for one of nature's most elusive and beautiful secrets. The journey of the red sprite is a wonderful story of scientific discovery. It is a transition from myth and folklore to accepted fact. For decades, the tales told by pilots were just that, tales. They existed in the realm of unidentified flying objects and other unsubstantiated sightings. The 1989 video changed everything. It provided the first piece of hard, undeniable evidence. It moved the phenomenon out of the world of anecdotes and into the world of atmospheric physics. It is a powerful reminder that there are still fundamental discoveries to be made about our own planet, and that sometimes the most extraordinary truths begin as a simple, unbelievable story told by a trusted observer. Beyond their sheer beauty, scientists are now asking what effect these massive electrical discharges might have on the atmosphere itself. We know that electrical discharges can alter atmospheric chemistry. A normal lightning strike, for instance, creates nitrogen oxides. Do sprites do the same in the mesosphere? These high-altitude chemical changes could, in turn, have subtle effects on things like the concentration of ozone in the upper atmosphere. The sprite is not just a passive flash of light. It is an active event that interacts with its environment, potentially leaving a chemical fingerprint in one of the most delicate and least understood layers of our sky. This leads to an even bigger question. Could sprites have a connection to Earth's long-term climate? While a single sprite's chemical effect is minuscule, sprites are happening thousands of times every day, all across the globe. Over years and decades, could their cumulative effect cause measurable changes in the composition of the upper atmosphere? This is still a field of active research and speculation. We are only just beginning to understand these phenomena and their role in the vast, complex machinery of our planet's climate system. Remains one of the most intriguing open questions in atmospheric science. They are a newly discovered piece in a puzzle we are still trying to assemble. To understand the true significance of sprites, we can think of them as part of Earth's global electric circuit. Our planet has a constant, slow flow of electricity between the ground and the ionosphere. Thunderstorms are the powerful engines that drive this circuit, pumping charge upwards. Traditional lightning returns some of that charge to the ground. But sprites, jets, and elves are another pathway in this circuit. They are a mechanism for electricity to move between the troposphere and the ionosphere. They are not an anomaly, but an integral, though hidden, component of our planet's electrical system, helping to maintain a delicate balance that we are only now beginning to appreciate. Let us visualize the invisible forces at play. Picture the storm cloud, its top heavy with positive charge. Imagine invisible lines of electric force reaching up from the cloud top, connecting it to the negatively charged ionosphere far above. These lines represent a building tension, a stored potential energy. Now imagine a powerful positive lightning bolt lances down to the earth. The base of those lines of force is suddenly ripped away. The entire field recoils and snaps, and in that moment of sudden, violent change, the air itself in the mesosphere gives way. It is in that moment of electrical breakdown that the structure of the sprite is born, a perfect, luminous fossil of the invisible electric field that existed just a millisecond before. Let us narrate the birth of a single sprite, moment by moment, in the deep quiet of the upper atmosphere. First, far below, a massive thundercloud generates a powerful positive charge at its anvil-like top. A bolt of lightning, a positive giant, leaps to the ground, taking that charge with it. Almost instantly, a wave of electromagnetic energy expands upwards. This wave creates the faint, expanding ring of an elf, the overture to our performance. A fraction of a second later, the electrostatic field above the cloud collapses. A diffuse halo of red light appears, a ghostly sphere 50 miles wide. Then, from this halo, the main event begins. Bright spots of ionization form and immediately cascade downwards, branching into the delicate red and blue tendrils of the jellyfish sprite. For 50 milliseconds, it hangs there, a silent, 30-mile-tall apparition against the stars. And then, as quickly as it came, it is gone. The darkness and silence return. If a sprite could make a sound, what would it be? It exists in a realm that is virtually silent, the air too thin to carry sound as we know it. But we can imagine. Perhaps it would not be a loud crack like thunder. Maybe it would be more like the soft, rustling sound of silk, or the faint, humming crackle of static electricity, amplified 1,000,000 times over. A sound that is vast, but gentle, a deep, resonant hum that fills the entire sky for a moment before fading back into the profound silence of near space. It is a silent spectacle, and so we are free to give it the soundtrack it deserves in our own minds, a sound as ethereal and fleeting as the light itself. The discovery of sprites on Earth naturally leads to a fascinating question. Could these phenomena exist on other worlds? We know that other planets in our solar system have powerful lightning. The Voyager spacecraft detected lightning on Jupiter, and the Cassini probe confirmed it on Saturn. These gas giants have massive, violent storms that dwarf anything on Earth. Is it possible that high above their turbulent clouds, their own versions of sprites and elves are flashing in the alien skies? Perhaps they glow in different colors, depending on the gases in their atmospheres. The search for extraterrestrial TLEs is an exciting frontier, a reminder that the beautiful physics we discover here may be a universal language, spoken by storms across the cosmos. Let us take a moment to appreciate the human element in this story. The patient scientists, the observant pilots, the dedicated storm chasers who spend countless nights staring into the darkness. Their work is a testament to human curiosity. Imagine the feeling of being the first person to capture a clear image of a sprite, to prove that the stories were true. It is a feeling of having pulled back a curtain on reality to reveal a hidden layer of beauty. It is the joy of discovery, of confirming a whisper of wonder, and of sharing that new vision of the world with all of us. Their work allows us to see these ghosts, not with our own eyes, but through the lens of their dedication. Ultimately, the red sprite is a beautiful symbol of the unknown. For all of human history, they flickered into existence above our heads, and we never saw them. It makes one wonder, what else is hiding in plain sight? What other phenomena exist just beyond the limits of our senses, or just outside the scope of our current technology? The story of the sprite is a lesson in humility and wonder. It reminds us that the world is filled with secrets and that great mysteries may still be waiting for us. Not in distant galaxies, but right here, in the quiet, unexplored corners of our own home. As you continue to drift deeper into relaxation, imagine you are one of those lucky observers. You are standing on a quiet prairie, far from any city. A massive storm flickers on the distant horizon, too far away to hear. You watch patiently. The sky is filled with stars. And then you see it. For less than a heartbeat, a colossal, silent red form materializes above the cloud. It is shaped like a giant tree, its roots reaching down towards the storm, its branches reaching for the stars. You are not even sure you saw it, but the image is burned into your mind. You have seen one of nature's most profound secrets. You have seen the ghost above the storm, and you feel a sense of connection to the quiet, immense power of the planet. After the sprite vanishes, a deep calm returns to the sky. The space where the 30-mile-tall creature of light existed is now just empty, dark space, filled once again with the distant, steady light of the stars. The storm continues to rumble far away, but the secret performance is over. All that remains is the memory of the flash, a quiet imprint of a spectacular event. This is the natural rhythm of the upper atmosphere, moments of incredible, fleeting energy, followed by a return to a state of profound peace and silence. Allow that feeling of peaceful, silent darkness to wash over you now. The calm after the flash, the quiet that follows the beautiful, secret dance in the sky. Tonight, we have journeyed far. We traveled from the familiar world of a thunderstorm into the thin, cold air of the mesosphere to the very edge of space. We witnessed the birth of red sprites, these magnificent, fleeting apparitions of light. We learned that they are not ghosts, but a real and beautiful expression of our planet's immense electrical energy, a silent conversation between the weather below and the cosmos above. For centuries, this incredible spectacle was a secret, hidden by its own speed and subtlety. Now it is a secret we share, a reminder of the infinite beauty and profound mystery that still exists in our world, waiting to be discovered. The universe is filled with such wonders, and sometimes you need only to look up above the storm to find them. Thank you for joining this journey tonight. If this story has helped you relax and find peace, please consider liking this video and subscribing for more lectures for sleep. We would love to hear from you in the comments. Tell us, what other natural mystery fills you with a sense of wonder and calm? For now, let the image of the silent red dance fade into your dreams. Sleep well.